Hey you guys, welcome back. Today we're going to go over multiplying and dividing fractions. Before we do that though, fact number 15 about me. I got this Rubik's Cube over here in the corner. I like Rubik's Cubes. I think they're really fun. They kind of keep your mind busy, they keep your hands busy. I wish I had one to show you. Oh wait, I do. So look at this. It's really good and mixed up. I learned how to solve one of these things a long time ago. Let's see if I can still do it though. All right, it's going to be timed and recorded. So let's see. Ready, set, go. Wow, it feels like the pressure's really on now that I'm kind of being timed and recorded. I hope this goes well. Typically, it does, but now that the pressure's on, I'm kind of feeling it. Let's see, there we go, there we go, where's this? There we go. Yeah, I learned how to do this, I don't know, maybe like 10 years ago. I had some time off during summer, during the summer after maybe like junior year of high school, and I was like, I'm gonna learn how to do the Rubik's Cube. I feel like so many people know how to do that. I want to learn how to do it. So I spent, I don't know, a good bit of time, maybe a couple of weeks, practicing a lot, trying to figure out how it works and how I could do it. And eventually I got pretty good at it. So let's see. There we go. All right. If you can solve a Rubik's Cube and if you think you can beat me, let's definitely race one day. I have a few here. So anyway, back to the math. Let's look through this. We're going to go over multiplying and dividing decimals. Now, multiplying and dividing decimals is great because the math generally is not too bad. There's no denominators that I have to mess with. There's no lowest common multiples I have to mess with. Luckily, I can go through and just multiply the numerator straight across and then multiply the denominator straight across. All I have to focus on is simplifying those fractions if I need to. So let's look at number one. It's a multiplication problem. With fractions, all I'm going to do is multiply the numerators. 1 times 2 gives me 2. 4 times 5 gives me 20. Perfect, that's it. However, I do have to check for simplifying. This one I can simplify. They're both even numbers. I know every even number has a GCF, a greatest common factor of 2. So when I divide these both by 2, I get 1 over 10. Perfect. Look at the next one. I got a multiplication problem. Excellent. I get to multiply the numerators. 2 times 3 gives me 6. 3 times 5 gives me 15. And now I just have to go through and check if I can simplify. These both have a GCF of, let's see, what goes into 6 and into 15? Oh, 3. Perfect. Let's see. I'll divide both of these by 3. 6 divided by 3 gives me 2. 15 divided by 3 gives me 5. And that's it. Wow. Let's look at the next one. Oh, some negatives involved. Again, the process is still the same. Multiply the numerators. Negative 1 times negative 2. That gives me positive 2. 5 times 5 gives me 25. There is nothing that goes into 2 and 25. There's no greatest common factor. So that's it. Look at the next one. You get to multiply the numerators. Negative 7 times negative 3 gives me positive 21. 9 times 4 gives me 36. And now I just have to go and check, can I simplify? Let's see, what number goes into 21 and 36? I think 3 does. Let's just see if 3 works. Let's see, 21 divided by 3 gives me 7. 36 divided by 3 gives me, 12. I can't simplify it any further, so that's it. Let's look at the next one. Again, multiplying fractions is the best because I just get to multiply the numerators, then the denominators, and then check if I can simplify. It's awesome. Let's look at this one. Negative 1 times 7 gives me negative 7. 3 times 8 gives me 24. There's nothing that can go into 7 and 24. Nope, there's no greatest common factor, so that is it. Let's look at the next one. Negative 3 times 3, I'll multiply the numerators. That gives me negative 9. 8 times negative 4 gives me, negative 32. Now, there's nothing that goes into 9 and 32. There's no greatest common factor here. However, I can still simplify. Whenever I have one negative, like in this example over here, if I have one negative sign, I can put it in one of 3 places. In the numerator, like I have it over here, I could put it in the denominator, or I can put it with the fraction bar. It is completely up to you where you put it. As long as there is only one negative, you can put it any of those places that you would like. It's your preference. My preference is always the numerator, so that's where I typically always put it. However, you can put it anywhere of those three places, as long as there's only one negative. When we get two negative, it's a little different though. We have to remember that every fraction is really just like a division problem. So when I divide a negative number divided by a negative number, I get a positive number. So if I have one negative, I can put it anywhere. If I have two, I have to get rid of them both because that's really just a positive fraction. It's no longer a negative fraction when there are two negative signs. So that's how I want to simplify that one. Let's move down the page a little bit. Let me bring this up. Let's see. Come down, give that an erase. There we go. Let's move this back over here. All right, let's look at number 7. Oh, this is a division problem. So, division problems. We always turn division problems into multiplication problems. Now, you guys hear a lot of different phrases. The one you guys probably learned when you first did this was keep, change, flip. And I don't hate that phrase. It's cool. It helps kids remember the order to take the steps in. Whatever helps kids do that, I think is great. Sometimes kids get this confused with keep, change, change. And that is when we turn subtraction into addition problems. That second C over here is all about changing the sign. So kids can kind of get these mixed up. Am I changing the sign? Am I flipping it? What am I doing? Am I changing both? So whenever we do this, and give that an erase, I'm going to turn all these division problems into multiplication problems. This is the phrase we always remember. But essentially, instead of dividing by a fraction, I'm going to multiply by the reciprocal. Let me show you what that looks like. So I'm going to keep the first number the exact same. I'm going to turn division into multiplication. And then I'm going to flip the second fraction, or find the reciprocal of it. That's the real math word, and that's really important that you guys know that word. So look what I've done. I've kept the first fraction the same. I've turned division into multiplication, and I've flipped the second fraction. I found the reciprocal. So now the numerator is in the denominator. The denominator is in the numerator. So now this is just a multiplication problem. I'm going to multiply the numerators. 1 times 3 gives me 3. 2 times 2 gives me 4. Oh, it's kind of a poor circle. Let me do that again. 3 over 4. There we go. That's better. That's my answer, 3 over 4. Let's look at the next one. It's a division problem. I'm going to, instead of divide by a fraction, I'm going to multiply by the reciprocal, or that keep, change, flip method. So, first number stays the same, 1/4. Division becomes multiplication, and 9 over 10, I find the reciprocal. I flip that fraction, and now it's 10 over 9. Now this is just a multiplication problem. So I can go 1 times 10, multiply the numerators. 4 times 9 gives me 36. And now I just have to check if I can simplify. Whenever I have two even numbers, I know that I can simplify. Every even number has a factor of 2. It might take me a few steps, and I might have to simplify a few different times, but I know 2 always works for even numbers. So 10 divided by 2 gives me 5. 36 divided by 2 gives me 18. And there's nothing else I could simplify this with. There's no other greatest common factor, so that's it right there. Let's look at the next one. Again, another division problem. I always turn division problems into multiplication problems using that keep, change, flip method, or just remembering to multiply by the reciprocal. Same thing. And remember, the reason we do that is because multiplication is kind of a lot easier than division. I mean, if you want to try and figure out how many times 6/9 goes into negative 1/3, wow, that's kind of tough to do. Instead, we use this because we know that dividing by a fraction is the exact same as multiplying by the reciprocal. So I'm going to set this up. Negative 1/3 division becomes multiplication. I'm going to find the reciprocal of the second fraction. So now this is negative 1/3 times 9 over 6. Let's go multiply. Negative 1 times 9 gives me negative 9. 3 times 6 gives me 18. Now let's see, what could go into 9 and 18? Oh, 9 could actually. 9 here would be the greatest common factor. So negative 9 divided by 9 gives me negative 1. 18 divided by 9 gives me 2. And I can't take that any further, so that's my final answer, negative 1/2. Let's look at this one. Another division problem. I'm going to change it to a multiplication problem. The first fraction stays the exact same. Division becomes multiplication. I'm going to find the reciprocal of the second fraction. So negative 8 over 10 is now negative 10 over 8. Now, this is how I always do it because I always keep the negative sign in the numerator. Even when I find the reciprocal, I still keep the negative sign in the numerator. And you can do that as long as there's only one negative. You can put it wherever you'd like. However, a lot of kids do this, and it's just fine. They have the 10 in the numerator now, and the negative 8 in the denominator. Not a problem at all. You can do that too. Okay? Either way, you get the same answer. But I always keep the negative right where it is in the numerator, and I go from here. So, this is just a multiplication problem. Negative 2 times negative 10 gives me positive 20. 10 times 8 gives me 80. And now, if you can't tell that 20 is the GCF here, that's totally cool. Maybe you can just tell that 10 is the GCF. Like 10 is a factor of both of these. If I don't think that it's 20, I could take it step by step. What if I just thought it was 10? Let's see what that happens. 20 divided by 10 gives me 2. 80 divided by 10 gives me 8. Now look, I still have even numbers. I know every even number I could divide by 2. That's always a factor. So 2 divided by 2 gives me 1. 8 divided by 2 gives me 4. I get 1/4. So it took me a couple of extra steps, but I get the same answer in the very end. Because if I had divided these both by 20, the actual greatest common factor, I would have gotten 20 divided by 20 is 1. 80 divided by 20 is 4. Would have given the same thing, okay? Sometimes we have to go in steps, and that's all right. Let's look at this last one. Another division problem. So negative 5/6, I'll keep it the same. Division becomes multiplication, and I'll flip the second fraction. I don't get rid of the negative. I don't change the sign. All I'm doing is finding the reciprocal. So I'm putting the denominator up top and the numerator down below. So let me go ahead and multiply. Negative 5 times negative 10 is 50. 6 times 5 is 30. Now this is an improper fraction. We always want to convert those into mixed numbers. That's the simplest form. So whenever I do that, I look and see how many times does 30 go into 50? Well, that goes once. Let's see. Then there's 20 left over. I keep the denominator the same. And then I can actually simplify this a little bit further because these are both divisible by 10, that fraction. So I could do 1 and 2/3 as my final answer. Notice how the mixed number doesn't change. The whole number, it stays the same. I'm going to give that a quick erase to get this last one. Now there's no denominator here, but I know that every whole number has a denominator of 1. So keep it the same. Division becomes multiplication, and I'll flip the second fraction. So now I got negative 5 over 1. Now, when I multiply this, negative 7 times negative 5 gives me 35 over 1. And I know that every whole number is over 1, so really this is just 35. You guys, thanks for sticking around for the whole video, and I will see you in class.